Hey folks, thanks for joining. Welcome to the KAITO community call. We'll give it a few minutes for everyone to join, and then I'll volunteer as host for today. Does anyone else want to volunteer as note taker?
Sure, I can take it.
Okay, thank you. Okay, I think we can get started here. We have a good number of topics and then also demos. For any new attendees, welcome to the KAITO community call. This meeting is being recorded and publicly shared. We have a YouTube channel dedicated for this project that automatically uploads our weekly community call recordings. And just a quick reminder for the CNCF Code of Conduct, as contributors, maintainers, and participants in this community, we want to foster an open and welcoming community, and also be open to different suggestions, proposals, and discussions in this call today. You can check out our roadmap for active and future developments and join our Slack using this link here. Um, I do want to call out that we recently released a blog post in collaboration with LLMD. So it highlights the KAITO RAG engine with LLMD inference in a relevant use case in this blog post. So definitely check it out. It's linked in the meeting notes, and we got a call out from the LLMD community on Twitter, and then on LinkedIn it will be posted tomorrow. So definitely feel free to repost or yeah, reach out for content ideas for building out additional blogs. This was a really fun one to put together with Ernest. Okay, so do we want to start off with demos? In the past, we've kind of had to rush them at the end, so I'm open to starting off with them and then going into open topics. Who is planning on doing the demo for auto index?
Brandon is going to do the demo.
Yeah, that was me. I'm cool with going.
Okay.
Shouldn't be too long.
I'll stop sharing.
Let me see. Okay, here we go. Right. All right, can you guys see my screen?
Yes.
Okay, so a little bit of background. Been working on the rag. We've got a lot of things going well for us. We have full like document CRUD within the Feist vector store. We've got chat completions API working. So the next thing that we're looking to do is create a kind of like an automated way for customers to get documents into their indexes. And to accomplish that, the idea is to create a CRD that has the definitions of where we can fetch documents from, where to put them, and potentially, if this is something that can be scheduled, run over and over again, then we can allow that, right? So I'll walk through kind of what the spec that I have right now looks like, and then I can show you a little demo on the static data source side. I don't quite have the GitHub side working yet, but yeah, so this is the spec, starting off with a RAG engine ref. So this is just going to be a reference to the RAG engine running in your cluster. And then an index name, which is the index where the documents will be stored. Your data source spec, which for now...
Brandon, can you zoom in a bit? So,
Oh yeah, sure. Can I zoom in? Or maybe I'll just resize my window. Hold on. Is that better?
your control plus.
Control plus. It's doing nothing. Oh, there it is.
Okay.
Okay. Too
Yeah.
bad.
And
All right, that good?
Yeah.
Okay. All right, so continuing on after the RAG engine ref and the index name, your data source. And for now, we have Git and static, which I'll kind of talk about in a little bit. Credentials, at the beginning, we're just thinking about handling, a token and a secret that we can use on, requests when needed. Schedule, since this is going to be a job spec at the base that we can reuse in a cron job, then this will be used in the cron job scenario. If the schedule isn't present, then it will just be a job, run once. Retry policy, this is just kind of the max retries we have for the job. And then suspended is just the simple bool. It is on the cron job spec, so it's an easy way. We can just edit this and then continue to have the cron job, but not run it. So going through to the data source spec, like I said, we're kind of only doing Git and static right now, with Git looking like repository, which is your repository URL, branch, so the branch within the repository. Commit is optional. Paths, which will be the paths that we look at within the repository, and exclude paths, which we will not look at. If you add a commit, this will act as only looking at that single commit. So it's kind of like without a schedule, you're only going to run this once on this one commit. And then for the static data source spec, we just have endpoints. And so this will just kind of go through the endpoints, fetch the data, add it into your RAG engine index. Yeah, and then we have some random status stuff down here that will eventually be used. But I went through and I kind of set up what Ernest did in his blog post. So let's take a look real quick. I have a cluster running, and I have...
So Brandon, before you go there, maybe can you briefly describe what is going to be the controller behavior, and what is so are you going to make all the data retrieving logic in the controller, or I know you're going to...
No, right. So
Yeah.
we're going to have jobs, and that was kind of like the whole scheduling and the data source. You're only allowed to define one data source per auto indexer spec, right? So we'll have the controller. The controller will look for the auto indexer spec, and when a spec is created, it will look at your data source and config and create a job or a cron job, right? And that goes...
So maybe you can explain, why do you want to create a job instead of just making the logic inside the controller itself? Why do you want to introduce a job?
Oh, sure. Well, for some things, Go is just a difficult language, specifically for things like parsing PDFs. So it's easier to have a separate service, that we can run in whatever language we need to, right? If we need to do it in Python, it can be in Python, a little job that we run in Python. If it needs to be in Go, we can write one for Go for a different data source, right? So it gives you the flexibility of per data source, what do we need to do? Can it be handled with our, Python one that we're starting off with? If yes, then maybe we can just extend it. If not, then we can decide if we need to create, a different service under a different image that we can then pull and run a job with. Does that make sense?
Oh, yeah. I think just make it clear what is expectation and how this controller is supposed to work. So the reconciliation, what is the reconciliation logic here?
So for the auto indexer spec, it's just on creation. We'll throw one in, throw a new job in, right? And then it will actually look at the jobs that are running and be able to update the status, right? That's the idea. Now, it doesn't quite work like this yet, but that's the idea.
Yeah, but the thing is, as a controller pattern, right, you are going to make reconciliation, right? So you probably need to detect the drift with whatever. Basically, this CRD just tell you the desired state, right? So from the reconciliation, you need to check whether. So I'm going to check the index of the reg to see if it is different for what is expected in the CR. Yeah, I'm just curious.
The controller won't do this, right? The controller won't touch the reg. This should be on the service that runs and updates the reg, right? So you say we have desired state here, but in reality, let's talk about like the GitHub, right?
Okay, I see.
So without commit, right, we want to run on the main branch. So what's going to happen is we initially submit this auto indexer spec. It will have the main branch. So when we run our job, the auto indexer job knows, oh, hey, I need to fetch the main branch. And so once it does that, goes through, puts all the documents into the reg index, then it will save the state onto the status of the auto indexer, right? So we have a last commit here. So whenever it starts up, it can check for that last commit, right? So once it knows the last commit, then it can just go from there and do the diff between where it's at now and the last commit and update the documents, right? So it should know the state. And if we need to understand if the index is in the correct state, then it should go within the job itself, not the control. Sound good? No qualms. Anything else, Faye? I know you might have more questions.
It seems he left the meeting. I don't know why. I didn't find it in the meeting. Maybe Zoom is crashed.
It might have crashed. Okay, I'll continue on, and if he joins back up, then he can ask questions and I'll go back. But so here's kind of an example of one of the static data source auto indexers. Like I was saying, I tried to go for what Ernest did in his blog post where he was asking about NVIDIA earnings. And, without the documents, you have nothing. But when you add the documents, then you actually get a real answer. You can see that these are from the KAITO cookbook, the PDFs that he used for this. So I'll run through a few commands just so you can see. I am connected to a cluster with a rag running, and I'm just port forwarding it. So you can see here, we're listing the indexes in the rag, and we have nothing. Okay, that's cool. So now we can ask our question and say, tell me about NVIDIA. And you can see the response we get back. It's just kind of like, oh, we need to have this data, but we don't have this data. So what we can do is apply the static auto indexer. You can see it's created. You can see that there's a job that's created. Look at the pod logs. All right, looks like it finished, and you can kind of see here it's found those PDFs and it parsed them with a nice Python library and was able to add them to the index. So now let's go check and see indexes again. Well, rag now has our auto index static test that we defined in the spec. And then we can also look at the documents. And from here, you can kind of see some of the document nodes that are within the rag, talking about different parts of NVIDIA and things. So this looks good. It looks like we have the PDFs into the index. So now let's run the question again, but with the index. And so now you can see NVIDIA's revenue increased from 60 billion in 2024 to 130 billion in 2025. So yeah, this is just kind of like a simple way to get your documents automated and put into the rag. Any other questions?
Sorry, Brandon, my networking
Yeah.
disconnected. Yes. I know you have answered, but I'm asking, so are you going to periodically launch a job to see if the rag index server consistent with the desired state?
It wasn't in the plans. I think that the job itself should know the state that it needs to be in rather than the controller running a job. Because if it's not in the correct state, then the job should get it in that correct state, right?
So let's
So-
say you have this index created, but I accidentally delete this index.
Uh-huh.
If you have a controller pattern, the controller is supposed to recover it, right? So I'm just curious, what is the triggering? Clearly, you are not watching. There's no watching mechanism for the rag engine.
Correct. Yeah, there's not right now.
So there's no. So you have to have certain kind of the drift detection, right? You need to check the rag engine with the specific index to see whether the content match what you are expected.
So you think that if I create this auto indexer one-time run job, right? And it uploads documents. And I go through and I add more. That's out of
No,
compliance
it's
with
not
this,
even
right?
animal. It's like, how
Only if I delete.
yeah, it's like how do you make sure, we are always reconciliating to the desired state, right? Your CR describing describing the desired state, but the controller needs to make sure, whatever in the reg engine with this index is reflecting what you are desired. I know maybe we can maybe this is it's okay. We say this is still TBD, but
Yeah,
we do think we need to have some kind of the drift detecting, right? So mechanism that you need to know whenever the thing that we are reconciled is not the same as we are desired.
sure.
Yeah. Okay. That's all.
Yeah, I'll take notes.
Rita and Qinghui both have questions.
Hey, I know earlier you showed something with like git commits. Can you explain what that does?
Yes, sorry. Okay, so on the which side of the commits? Was it in the spec
Yeah, like here you
definition
have
itself?
repo branch commit, right? Why does this need it?
This was for running on a specific commit once.
But sorry, is this to pull the content from Git like some
Yes.
kind of Git repository?
Yes.
Okay. sorry, can you go, but then your YAML, the one that you just showed earlier, didn't have anything related to that, right?
Because this isn't a get data source, right? This is just a static data source
Okay, so you have different types for
of
data
data
source.
sources. Yes,
So what
correct.
are the types? Okay, static get,
That's it for right now.
gotcha. And what about authentication?
That's where we have the credentials, right? But to begin with, we're only doing token credentials, right?
Uh, okay, because we think most users would do this from Git.
Sorry, what do
I'm just
you?
trying to understand what is driving this experience.
So I think that one of the big factors is, let's say you want to have something like the PR agent, right? Where you want to have people, or maybe not even PR agent, but just working on a repository, right? And so everybody pulls out their own branch or their own commit, and they want to do like analysis on it or use it with um, Copilot, right? You could put this up to go fetch your specific repository and index your code into the RAG and have the LLM behind it and then be able to ask questions against it, right?
Okay, and so then, okay, I see. Sorry, I think you had like multiple commits. What's this? Like,
Okay, so sorry, where was it? This commit in here is the single commit that you're going to run on, right?
mhm.
Whereas we have a commit, the last commit in the status, which is the last commit that has been run on. So
Okay, gotcha.
if you
This is
don't
just the
include,
status.
yeah, if you
Okay.
don't include this commit and you only do it on main, right? And you have a schedule to where it will run every day, right? Then the latest commit that you run on will be the last commit that you ran. Sorry.
Okay, I see a bunch of hands up. I'll let others ask
Okay.
questions.
See Chinhui.
Regarding phrase question, is there a revision number in the index? Will you add a revision number in the index? Because you need to update the index after next sync.
Revision in the index.
Revision
In the actual
version,
RAG index or the auto indexer?
the reg index, because
The
your controller logic need to ensure the index in the reg engine sync with the git commit. How do you know the data is correct in the reg engine? Maybe you need a revision number in the index.
yeah, so that could be a potential solution. Yeah.
Okay, and my next question is, how could you explain how will you do a incremental update from last sync?
Sure.
Because
So
the new commit may be just edit to the existing file, and how did you got a incremental update on the index?
yeah, so everything is based off of the diffs. Right. So if I know the last index that we ran on and we're running on the head of the branch, then I can get the diff between those, right? And that will
Yeah,
tell me the
yeah.
files that have changed or deleted or been renamed, all of that, right? And it's just the algorithm that you run, which we already do in the PR agent, that can determine if it needs to be updated, removed, name changed, and anything like that.
So you mean you will firstly apply the diff on the existing files, and then you index the file?
Yes.
Okay. Okay, thank you.
I had a quick question about the data sources. In consideration of, let's say, different types of data sources around across different cloud platforms, do we
Mhm.
have maybe like a prioritized list of others that we would test with, or at least like validate those endpoints?
We don't have any prioritized lists at the moment. I think another big one was kind of blob storage. That would be
Yes.
important for people. So I think maybe across clouds, that would be a good one.
Yes, I would agree there. Yeah, I could also share like other user asks for blob storage specifically is what I was gonna mention. So
Yeah.
yeah, we can also like discuss that offline.
Okay. Yeah. That'd be good. Just taking notes. And who else has their hand up? Good.
Yeah, I can go ahead. So I wanted to ask, like, are we, as we are indexing all these documents in the RAG, like, are we using any vector database here? Could you please provide some insights on that part?
Yeah. So we use the FICE in-memory vector store. That's just kind of what comes with the RAG right now.
Mm-hmm. Got it. And for this, like get best, like the corpus that you're putting in. So like if I want for some particular commits, let's say how you are, separating, if I say like for certain number of commits, I want that to be the only corpus. So how you're managing that logic? Can you please provide some quick glance on that part, if there is any?
So when you say specific commits in corpus, can you explain a little bit more about what you're trying to accomplish?
Let's say I have my Git tree and I have, like 10 commits there, but I just want some commit from commit 1 to 4, these 4 only to be my corpus, not the rest. Is this
So,
is that possible to do here?
well, if it's like linear commits, then your best bet would be to add that commit string within the Git data source spec, right? So this commit, you just be the latest one in that linear tree of commits, right?
Yeah.
And that should handle that scenario. If you
Yeah.
wanted to do something different where you have random commits from across the tree, then you might have to create your own branch and then pull in the commits you want and run it based off that.
Got it. Thanks.
And Bengchi?
And I want to, sorry, I want to ask about the incremental update.
Yes.
If the specified branch is updated, and your controller reconcile will start a new job to index the diff contents, yes?
No, right? So the idea here is that this definition will spawn a cron job if you have a schedule, right?
Oh, okay,
So
okay.
eventually the job will be rerun and understand the last commit that was indexed and be able to look at the diffs between those two commits and then update the index based off of those diffs.
Okay, okay. So the job is according to this schedule to index the updated
Correct.
contents. Okay. Thank you.
Hi, Brandon. Like, I will have you go through with all of the previous like Kaito like repo? Have you tried that?
Not with this yet. The Git data source doesn't work yet.
Okay.
Still working on it.
Okay, I see. Like, I'm not sure. Like, and is there any way to? It's just I'm trying to do something, but like, is there any way to like for you to analyze like the files between Git files? Is there any way to do that? Maybe it's not in this one. Maybe I think maybe we can try add something in this like data source or something. Is there any idea to do this?
To only look at files?
No, like for now, I met problem is like to analyze the relations between different like files. So I don't have a very efficient way to do this. I'm not sure if you have think about that.
So what kind of relation, I guess, do you mean?
If there's something like if like we have Python and we have Go language, right? Some Python in the Docker image and and then put into as an image in the Go language thing. So we have set some environments to pass that. So this kind of relations. So I don't have an idea to analyze. Okay, if you still don't think about it, so just skip this one.
Okay. I don't think I've quite thought about that yet.
Yeah, cool.
Hey, earlier you mentioned you're using tokens, right? For
Token as in like GitHub token, right? That would be your credential that you store in the secret.
Okay, so you're still thinking about Kubernetes secrets.
Yes, of course.
Okay. Okay, we can take this offline, but I think there are different ways to make it more secure. I'm not sure if it's a simple secret is the way to go here.
Okay.
I can see how users might be like pretty nervous about sharing their like Git tokens. But it sounds like this is not like the initial use case probably, right? It's more for advanced users.
Yeah, secrets. I mean, I guess if you have a private repo, then potentially that would be used. But if it's just public repos, then you'd be fine with the Git data source.
But we do
Yeah.
think Git is our major use cases. So Rita, if you
Oh,
have
it is.
you have a better ideas about the secret management, yeah, let us know. I only know the Kubernetes secret.
Uh,
I am feeling user can provide a limit permission token for the Git access. Like the PAT, you can give a limited permission, just a read permission to that token. And you can use that token to pull the
I think even if it's just read, I think it depends on how you expose that. Like again, if it's a secret, it might be okay. If it's like, service account, as long as you can mount a volume, you have access to it, right? So
uh-huh.
again, we typically recommend people to use something like Secret Store CSI driver where you store the
Okay.
key in like Key Vault and then have the Secret Store CSI driver pull it. That's just one example.
Okay.
I can share
Agreed.
more details. Is this a PR or this is still just a design?
I'm still working on it.
Okay, I'm happy to like add that to the like as a comment somewhere, just to continue the conversation.
Yeah, definitely.
Okay, cool. Do we have any more questions for Brandon?
Looks like no. I'll follow up with people afterwards.
Thanks
All
for
right,
the
I'll
great
stop.
demo. I can take over the screen share again. Just in the interest of time, we'll probably be able to hit like one or two more topics. I do want to, as I'm sharing screen, maybe Faye, you can go into the first open topic.
Yeah, let me do that. So my networking is not very nice. So hopefully we can make make this presentation.
Did you have anything you wanted to share screen for?
Yeah, I'm sharing.
Okay.
So can you see it?
Not yet.
Let me see. Share. How about now?
Yes, can see it now.
Let me quickly go through it. So the idea is that we're trying to, in this community meeting, we need to discuss, I want to discuss a high-level discussion about introducing a new workload called KAITO inference set. Let me quickly go through what are the problem we are facing right now. So the major problem that we're facing right now is, while Limbo was trying to add in the scale API support in KAITO workspace. So we find out a tough problem because the current workspace CRD cannot satisfy the scale path requirement for the scale server resource. So that, as you can see in the annotation for Kubi Builder, Limbo was setting the scale path is a dot spec, dot inference, dot replicas. This path is actually wrong because if you look at our workspace structure, we don't have something called spec. So we directly have the resource spec, inference spec, tuning spec, etc. So no, so if we don't have this spec in the past, when you apply the CRD, we are going to trigger a validation error. So those validation checks was added about 7 years ago. So we have no idea why the scales, what is the reasoning why the scale sub-resource has to be under spec? We don't know. But it's almost most impossible to change the upstream behavior, right? So if we remove it, we will trigger the error. If we don't remove it, basically, if we just write a code like this, the validation checks passed, but the scale API call is going to fail because when API server trying to change the replicas based on the spec path, and it find the object doesn't have this path available, so the scale API call is going to be failed. So that's the number one problem we are facing right now. To resolve this problem, we have no choice but introducing a breaking API change. So as I show in the example, we have to add a spec and moving all the either resource, inferences, and the spec. So it's doable. Yes, it's doable, but it's going to be a breaking API change. So which means we have to implement the conversion webhooks if you bump in the API version. We have to bump in the API version in the first. Secondly, we have to implement the conversion webhooks. That's number one problem. Okay. The second problem is while Limbo was working on this, adding the whole changes to support the scale API. I don't know what else I saw the thoughts, but in my opinion, I feel adding this supports introduce non-trivial complexity for the workspace, both API and the controller. As you can see, we introduce quite a few actual fields in the API spec. And if you look at the controller, now it needs you to node count calculation and scale up and scale down node claim based on the scale operation. So it is not a very simple and straightforward logic. Like you have to deal with the scale up before you start reconcile the workload, like deployment. But for scale down, you have to scale down workload first, then remove the node. So all this sophisticated logic and workflow you have to introduce to make sure the controller is doing the right job. In general, I feel the workspace CR becomes more and more complex. This is my personal feeling. So if you have so similar, maybe we can discuss later. And the last problem that I can see is based on our original plan, we were planning to using the leading working set to deal with the scaling for our distributed inferences, which requires a stable sets as a workload, right? When I closely look at the design of the LWS, I feel the LWS does not fit our KAITO's inferences use case very well. So the reason why I'm saying that is if you look at the diagram of the LWS, it basically has one leader's stable set and per worker, and they have every replica has a per worker stable set. So this is the overall hierarchy. So in short, if you have n replicas, you are going to have n+1 stable sets. I think this design is reasonable if the worker stable sets needs to be scaled by for your use case, for the use case. But in KAITO's inferences, it is slightly different because the pod count of the stable sets that we run the distributed inferences is a fixed value. So basically, once you start the distributed inferences, the number of replicas is a fixed one. You cannot change it. So whenever if you change it, you have to pretty much rerun the entire thing. So this is not something that can auto scalable. And I can get the design idea because this pattern may reasonable for trading, because I can foresee some training framework you can dynamically adjust the workers during the training. Depends on the the load or whatever. But I don't think this is a very nice fit for KAITO, because in KAITO in general, for n replicas, you probably only need n stable sets. Overall, if you consider all the problems that I have mentioned, and we are going to introduce a breaking change anyway. So I discussed with the other maintainers. We try to say, hey, how about we just stay back and try to revisit the auto scaling design again to see whether we can have any other options. So, but when we consider the redesign, we make sure, okay, the original decision of using the KAITO integration with a plugin, we try to make that part unchanged. So we still need to integrate with KAITO. We still need to introduce a KAITO plugin so that they can the plugin can just call the whatever the resource, the scale sub resource. Now the whole problem now coming to, hey, how can we have another way of support this scale sub resource instead of our original plan to introducing the scale sub resource in the workspace here? So currently the current plan is we can leverage what or original concept we already built in the Kubernetes. Basically, we have the pod as a basic scheduling unit, and we have another workload, either replica set or which is a workload that dealing with the scaling of the basic block. So we are trying to see maybe we can leverage the same pattern for workspace. We are going to, so the name is still TBD, but I'm trying to just call it as an inference sets. It is going to be something that's similar to replica sets. And the workspace here is going to be the basic scheduling unit, like the pod. So the idea is workspace doesn't deal with any scaling. For any scaling, we are just going to rely on another workload. And the workload is called inference sets. So similar to replica set, the inference sets just solely focus on two major functionality. One is scaling. Second is just a route, like the general Kubernetes, the workload Kubernetes general Kubernetes workload is the main task of the general Kubernetes workload. The idea is very simple. So it's like your workspace just deal with the single operations. So single instance operations. We will just add the scale sub resource in the inference sets. And we are just all the autoscaler plugin is work around the inference sets to do the scaling. Again, this is a very high level idea, so I didn't dig deep into the exact API spec for how it is going to look like. But there is some high level idea. I just give you an example. Apparently, just like normal clearly we will just add spec here. We put replica and the spec. We have selectors. All these follow the convention, Kubernetes convention for the workload. And we have a template, and the template here is going to be the template of the workspace. It is not a pod template. It's going to be a workspace template. Some of the high level design can be we will make the spec replicas as a scale path for the scale sub resource. And in the workspace template, we only expose the inference spec in the workspace template, because in the workspace we have both inferences spec and also the resource spec we should expose. But we are not going to expose the tuning spec in this inference sets, because in general the tuning work doesn't support our scaling right now, at least right now. The scaling operation is pretty straightforward. It's like you play with the replica, we just create a number of the workspace. You reduce replica, we just delete a workspace and all the associated nodes. For the update, maybe it's still TBD. Some ideas, maybe you can follow the same restriction in the workspace nowadays. It's like almost all fields are immutable, but you can change the adapters. So if you change adapters here, we can just update the workspace, the adapters. So all the other fields we can just deny the change for all the other fields. Update strategy. I didn't fully thought about this. Maybe still TBD. Can be support max search, max available, etc. So it's going to be somehow similar to what deployment currently have. For the service, we are going to at least exposing highly services whose endpoints point to the every service endpoint of for the every workspace replica. This is if you check AWS, they have the similar logic. So to expose a global, the highly services for all the replica endpoints. Yeah, this is my general thought process of this API. Again, details we can still TBD. So the pros and the cons of this approach. So the pros I can see is when we introduce an inference set, the new workload called inference set, we have a clear separation of concerns. Workspace focus on the provisioning, the entire the model provision workflow, and the inference sets solely focus on the scaling and the rollout. And this is kind of mimic the standard design pattern of Kubernetes workload. And if we make this separation, the workspace API is going to be simpler. We can remove all those extra fields, and it stays as a basic building block. And as I said, if we just change scale based on the workspace granularity, so we don't have to deal with individual node claims scale up, scale down. So that part of the logic is gone. It's just you don't need to deal with node claim deletion at all. You just delete the workspace. From the controller's perspective, this is much more easier compared to you need to reconcile multiple node claims. And last but not least, there is no LWS dependency anymore. So this is our own controllers. We make sure we maintain the whole life cycles and the release, etc. The cons, I would say the biggest, the thing that may raise concerns, this is going to be a significant UX change in the sense that if we introduce something called inference sets, literally whenever from now on, whenever we want to introduce KAITO or describe KAITO, maybe we will start with inference sets rather than the workspace. So there are some implications about how our document is going to look like, how roles in all other future integration is going to look like. Another cons I can see is if we just nowadays if we do this, we will see multiple single replica deployments exist because we don't scale in the workspace. So for the deployment currently, we will have for every single node workspace we use deployment, and you will see multiple single replica deployment, which looks a bit weird. But I think we can somehow mitigate this because we can choose to. If this is the case, we can choose a state set as the only workload used in the workspace. So then it's kind of another simplification, unification that can make people less confused about, hey, why you have a single replica deployments. Of course, you need to introduce if we introduce inference set, we will have an extra CRD, extra controller needs to maintain, and this is the overhead we just cannot ignore at all. Yeah, that's overall my presentation for this. I'm open to any comments, suggestions, any thoughts about this. Rita?
So just to clarify, so can you go back to the YAML, the 7? So when replicas, let's say we change it to 2 for that inference set, it is actually deploying a new workspace. Is that right?
Yes.
So it's really is a number of pods. It's whatever the workspace, right? Like you're not doing one pod at a time. You're doing like whatever the workspace has.
Yeah.
So how does that work for multi-node distributed inference? Like how does this impact that?
You are going to create another workspace. That workspace is going to create another state set with n pods. Does that answer your question?
Yeah, I'm just trying to think like today as a like when I, as a user, when I create the workspace, I need to think about how many nodes and how many pods I need potentially, right?
You
So
probably don't. So because we are deprecating the counts field in the resource with our automatic node size calculation. So let's say, just look at this YAML. So at this moment, you don't need to know how many nodes is going to be needed. We are just going to calculate the node counts based on the skill that you provide and the model that you want to run.
got it. So let's say replica is 1, and let's say hypothetically you determine I need like 2 of these, right?
Yeah, yes.
So with Kata, how, like, if that says, hey, scale out, replica goes up to 2.
Yes.
So anytime it's always an increment of 2 of these nodes.
Yes.
Is
Because
that
we
a
need to create another
concern?
workspace.
Is that a concern? Like, what if
we
we don't need 2? What if we just need 1 more?
Th-
Because it's not granular enough, right?
yes, but for workspace, it is okay. So currently it is not a problem because currently we have our workspace follows one pod, one node philosophy. So we simplify the problem. In the future, if we want to support finite granularity nodes, we are going to significantly change the way that we manage nodes in the workspace. But I don't think this API is going to be changed because this API anyway, we don't want to expose how many nodes you want to do because we want to do it automatically. So so you're saying that if the work, so can be a case this workspace doesn't need 2 nodes, right? It may just need 1.5 nodes, assuming you can do finite granularity scheduling for the for the
Yeah,
GPUs.
I guess the other concern here is like, say when you're dealing with like replica set, right? Or deployment, when you change a skills, when you change a replica's number, it usually translates to now you need more resources, right? And usually that's a replica of the resource that's in this YAML, right? But with the fact that the workspace is abstracting the resource aspect of all this, when I change replicas to 2, it does not tell me how many actual resources is this diff
It
is
doesn't. It
translate to,
doesn't. It doesn't.
right?
But we can tell you, I mean, it doesn't, let me put it this way. You don't know from the, you don't know. You don't specify it in the spec, but in the status, we can somehow tell you. It's like you don't have to specify how many resources you need, but in the status, I can tell you.
I get that, but then what is the, like, what does the changing replicas from 1 to 2 mean then?
Changing the mean that you have a better capability to satisfy your inference request. You have more computer powers. Let's say without scaling, your workspace can only support 100 QPS. I'm just making it up. With replica with 2, you can support 200 QPS. Because this is the entire driven by the KAITO is like the auto scale is, this is auto scale, it's not a manual scale. The way we drive the auto scale is based on your inference service matrix.
Yeah, I think I understand what you're saying. I think it's just kind of confusing because, as you said, going from the instance type that the user provides to how many you actually need, that's been calculated for me, right? That is based on some like request per second, right?
No, that is not based on request. That's based on the model size.
Okay.
Yeah.
So then, okay, I think what you're saying is like, it's sort of like you start with a workspace starts with like a baseline.
Yeah, it's the same thing. So, let's say if you see this instance as a replica set, right? You change template to port template, and you just run Nginx, and that's all. I just tell you I run an Nginx service. How much performance is not specified in this, the spec. Instead, the performance, how many record of Nginx service, 100% based on your loads, your incoming traffic load, right? So that is auto scaling part. But from the deployment here is like, okay, this spec just tell you, hey, I'm running the Nginx. Whether this replica with this Nginx with replica one satisfy my requirement or not, I don't know. And the replica count is solely is controlled by the autoscaler, and the autoscaler is going to react based on whatever your needs for this service. The same thing here is like the inferences in this spec tell you, hey, I'm just going to run this model. And you have your incoming request to send in your inference request to the model. Whether one replica is ready enough or not, we don't know. So how many replicas solely depends on how our autoscaler was designed.
Okay. I think I understand what you're saying.
Okay, any other questions? Let me see.
Just out of curiosity, are there any other projects that take a similar approach for inference set?
Other project with inference, I don't know. I don't see it, but with pod there are so many. But with
Well,
inference,
I think Kaito is the first one that's trying to do like auto calculating, like determining number of nodes based on the instance type and the model, right? I think that's something Kaito is very unique to Kaito.
so this
Usually for other
encompassing,
ones, you
yeah,
come
this
with the nodes.
encompassing, yeah, is so such is my understanding. If you look at the closest one, I would say AWS. But RWS is more leaning towards a generic, generic design. This is very specific for KAITO.
Yeah. Like honestly, I feel like this is kind of it's good and bad. Like it's good that you're like making it easy so that the user, I don't have to think about the number of nodes, right? But then it's bad because I don't know how many nodes I actually need. Because you're abstracting that layer of that layer of complexity for me. So what if I need to run X number of nodes? I wouldn't be able to. Like it's like because you're doing it for me as opposed to I tell you how many I need. Does that make sense?
I understand what you're saying, but let me see. In general, if people want to auto scaling, so okay.
I'm not saying there's anything like wrong with this. I'm just saying that's a difference of behavior that users may be surprised by.
All I can see is you start with replica one, and in the status I tell you how many has been used, and you have a rough estimation. So it's exactly the same thing as you just start the workspace, because currently now the workspace is that you have same problem. We don't need to use specify the replica count. We calculate it. We will choose the optimal, most likely the minimum count that you are going to need to run a workload. It's the
Yeah.
same thing. In the workspace spec, you don't know. You have no idea how many GPU you are going to need.
Yeah, I think this again, this like auto scaling experience works fine if user says, "Hey, Kaito, I want you to do everything for me." But things will kind of get weird if users decide to bring their own, right?
Oh, okay. Bring your own. We have another discussion. I have another discussion with Jonathan. We don't have time to discuss today. But to answer your questions, bring your own is likely to hit a case that you don't have enough GPU, 100%. Based on my discussion with Jonathan yesterday, the best thing we can do is now we fail it. It's like the actual replica just doesn't come up. we will have to make the error messages very clear so that user need to know, hey, I need to bring more nodes by myself, something like that. But when I design this, I wish this one also works for BYO nodes. It's not only say that this one only works for an AP case.
Yeah, maybe next time you can show how this translates to BYO.
Yeah, we can. Yeah,
Yeah.
BYO, the whole thing is you have to do the capacity planning by the user. So that's a whole different point, right? BYO, you have to do the capacity planning by the user. NAP, you don't have to because controller can do it. BYO, you have to bring up your nodes beforehand.
Yeah, again, I'm just thinking about how like other cloud native apps or tools solutions work. I think traditionally people bring their nodes and they expect their like, HPA and cluster autoscaler will take care of it.
Yeah. That's also the thing is in general.
Right. So I just want to understand how this will work with all of that, just to make sure we
I would
don't
say,
introduce too
no,
many new things.
sure. I would say I would say if you say workspace, if you want to completely remove this provisioning, like realize NAP planning parts, that kind of thing should be happen in the workspace. So it doesn't affect this API because whenever we want to introduce behavior changes, it's going to happen in the workspace API. I agree with you. Maybe in the end, eventually it's going to with the DRA. Eventually it's going to be just planning parts and relies on class autoscaler.
I have one more question. I know we're already over time, so I'll keep it short. But you had mentioned capacity planning, and from my perspective, I feel like capacity planning is needed in both cases, right? Where like the user knows how many GPUs they even have access to in total.
Oh
So
yeah.
how do they like tell or how do they specify that this is like the max that you should be able to hit? Otherwise, like
Yes, sure,
there's no
sure.
other available.
Sorry, I need to make it clear. So capacity planning, I'm not talking about quota capacity planning. I'm talking about you need to provision the node by yourselves because there's no node out provisioner. You bring your own node.
Oh, okay.
So I'm saying that the capacity is the available GPU nodes in the cluster. It is not the available GPUs in your quota. That's different.
So even if Kaito is determining the number of GPU nodes needed for the model, it would
Oh
need
yeah,
to like we don't want it to fail because it can't actually
but it has to, right?
reach.
So if you BYO only have one node, but you want to run say DeepSeek, I have to fail you because it's just impossible.
Oh no, I think what Sachi is asking is like, say in this case, since I'm saying, hey, Kaito, you take care of the math, right, to determine number of nodes. That's why I don't actually know. I don't know until this is deployed and I look at the status field and I see, oh, okay, this model needs, say, 3 nodes,
Okay.
right?
Yeah,
And by
Okay.
then it's like pretty much too late because, hey, I don't have 3
Okay.
A100s,
right.
Okay.
Yeah.
We
right?
can do that. We can 100% do that in the validation of this inference sets. We can do that.
Like, how do you do that? Like, you don't know what
We know we can run the algorithm in the validation. That's a static algorithm.
Sorry, no, I meant like the only way you would know that is you call like the cloud providers APIs to see
Yeah.
how many quota they have, right? Oh, sorry, what's the capacity they have?
Oh, you are talking about that? So you're saying
Yeah,
that I need
yeah,
two, but my
that's
quota
the
only have
difference
one.
between
Okay.
the human, the operator making that decision versus Kaito making that decision.
So then what is the suggestion? I just don't know what is suggestion. So if you
I don't
only
think it's a suggestion. I think we're just calling that out as a sort of a like an experience gap, right? Is because the user is offloading that decision to Kaito, it's very possible that Kaito will deploy and it will fail because they don't have the capacity. because
Exactly.
you're
don't.
Like, is there a way to specify max replicas, for example? Like it just if it determines that this model just needs too many GPUs more than what the user actually has capacity for, then it does not proceed. Right? Like, isn't that something
It's
the
not,
user
wait,
should
wait, wait.
know
So,
before?
wait. I think such your request can be easily achieved by adding some field in this API. But I'm asking is the read what I'm confused is the Rita's question. So I don't see why you think we automatically decide the node count is going to make a situation worse.
well, because let's say I bring my own nodes, I know how many A100s I have, right? Whereas if I offload to KAITO, I don't know how many KAITO is going to say I need until after KAITO deploys and I see, oh, KAITO thinks I need 4, but actually I only have 3.
But if you tell me you only have 3, you cannot even run this workload. So what's the difference?
It's a fail early versus,
Yeah.
right?
You can still fail early
How?
because we have a validation. When you create a workspace, we can validate it. You only have 3 BYO nodes, but this model needs 4. We can fail.
How does KAITO know I only have 3 A100s?
We can just list all the nodes in the cluster, right? It's BYO.
No, I'm not talking about BYO. I'm talking about the KAITO default or whatever, like non-BYO. Non-BYO, you don't know what my A100 capacity is, right?
Yeah, but okay. So now let's assume users know I have only one. We have 3 A100. So how can KAITO do the things better? Result in the auto calculation. So basically, you tell me, user can specify in the count. Say basically, you say we have 3. In the resource spec, users can tell we have 3.
I think what Sachi is suggesting is there's a field users can tell KAITO like
Yeah, min and max. Like
min and max, right? But by the way, this is what AnyScale does.
Hmm.
They have a min and max too. But anyway, I think that's what Sachi is saying.
Yes.
That's okay. That's okay. Min max in this inference set with min max count. That's okay. That's no problem. So I'm leaning toward okay. So I see what Rita was saying. So I guess what your suggestion is we shouldn't deprecate the count field. Just make it optional. If you specify in the resource spec say count 3, we just do a validation check against that count 3.
Fei, then I think we need to change that, right? So for now, like the count is exactly the thing, but I think what Sachi means is a maximum count.
No. I'm not talking. So if you have a scale, auto scale max, min and max, that field is in the inference set. I'm talking about is the workspace. We have the resource spec, right? The resource spec has a count, which means exactly how many GPU you want to use with this skill to run the workload, right? So I guess what Rita was saying that, oh, I know I only have a quota of 3. So in the workspace, I can just tell exactly skew with count 3 and try to run a workspace. And the workspace can fail earlier because we know you specify 3, I can tell you exactly this 3 doesn't work. Rita, does that answer your question or make you feel the UX is better?
Yeah, I think we can figure out where's the best place to put this, like min max, whether it's workspace or inference set, because I can see pros and cons with both. But
Okay.
regardless, right, the question is when it's not BYO, okay? When KAITO is
Okay.
calculating this,
Agree.
we want to fail early.
Agree. No problem.
Right.
Yeah.
And I see pros and cons with either like do this at the inference set level or a workspace level.
Okay, agree. I think we can in the inference levels indicating what is a max GPU kind of quota kind of thing. I just need to figure out the field or write API name. But I got what you're saying. I got what you're saying.
Okay, sounds good.
Yeah, it's
Yeah,
over.
we are 10 minutes over time, so we can drop now, but thanks everyone for the presentations. We could follow up on this, like the API proposal. And I'll add this back in for the next meeting agenda and the other topics that we didn't get time for.
Okay, thanks, Ella.
Thank you.
小米，一会儿走吗？ 等一下哈。1分钟你就下去吧。